Well, hello everyone. In class last week, we spent quite a bit of time on graphing. So let me review a couple of the things that we talked about when we create graphs. You see in front of us a graph. And let me remind you that when we have a graph, we have an x-axis down here. In this particular case, it happens to be time in minutes. That's called the x-axis. Over here we have the y-axis. On this graph it happens to be distance. I did a really nice job of circling that, didn't I? And we always make sure we label the axes of our graphs so that we know what the variables are in our experiment, because that helps us understand the graph. Graphs have to stand alone all by themselves. Remember in class I had you put a title on your graph. That's so that a reader, an observer coming to your work can see the graph and know what everything stands for on that. I talked also about how we always number the lines and not the spaces. So you'll see the number 10 is right on this line, the 20 is right on that line. Same thing on the y-axis, the 2 is here, the 4 is here. And then we put dots. And then after we put dots down, we decide what line of best fit goes with our graph. So when we talk about lines of best fit, I said we want to look for one of two kinds of line. We either want a straight line like this one up here, or we want a smooth curved line. And the data points on the graph will help us determine whether or not we have a straight line or a smooth curved line. I also mentioned in class that we want to be sure to look for those places where when we build our line of best fit, some of the data points may be above our line. So I'm down here on the right hand side with this smooth curved one. That one's a little bit above the line. This one's a little bit below the line. This one's a little bit above the line. This one's about a little bit above, and this one's a little bit below. So sometimes we have to find the average of the spaces between our data points in order for us to put in that line of best fit. So we talked before about the names of the variables that go on the x and the y axis. So on the x-axis, we call those variables either the manipulated variable. That means we're the ones who are manipulating the variable. We're the ones who decided that we were going to measure every meter when we rolled the bowling ball down the hall. Or sometimes we call that the independent variable. It's the one that stands by itself. Another way that I often describe it is it's the variable that we have control over as the people doing the investigation. So then the other variable always goes on the y-axis. If we're using the term manipulated, the corresponding y-axis term is called responding variable. If we use the term independent variable, then our corresponding term on the y-axis is the dependent variable. You can use either of those terms, but keep manipulated with responding or independent with dependent. Don't mix the two of them up. So in other words, don't call it manipulated and dependent. That's too confusing. But you do need to know the difference between those variables and which is the one that always goes on the x-axis and why it goes on the x-axis. And the answer is it's either the manipulated variable or the independent variable, and always goes on the y-axis because we had control over that variable. One of the things we can do now with graphs is we can actually describe the relationship that the graph is representing for us. So here's an example again of the same graph. This happens to be time and distance. When we talk about describing relationships off of a graph, what we do is we always tell what happens to the responding variable as the manipulated variable changes. And I've written it if we wanted to talk about dependent and independent variables down here. But we always talk about what happens here on the y-axis compared to what happens down here. So when we write our statements, we always describe and use the word for the responding variable first in our sentence, and then we conclude with the manipulated variable. So an example of that for this graph would be this. You would say that the distance, since that is the dependent variable, the distance does what as you go this way? Hopefully you just said increases. The distance increases as the time does what? Well, I went from 10 to 20 to 30 to 40. It also increases. So our describing relationship sentence would be the distance in kilometers increases as the time in minutes increases. That would be a statement that we could use as evidence to describe the data that we see on our graph. For your homework this week, I'm going to have you do some reading in general about graphing, but I also have a couple of worksheets for you to do. They're going to start off pretty simple and they're going to get more difficult as we go along. So the first one asks you is this same pattern right here. You're given a graph. It has the y-axis labeled, it has the x-axis labeled. You can see that in this case it's the speed of the car and how much gasoline in how much gasoline it uses in kilometers per liter. These are actually units that we don't usually use. We usually talk about miles and gallons, but in this case we're using kilometers per hour and liters of gasoline. So the question when you first look at this graph is, are the data points represented correctly? In other words, is this the line of best fit? And if this is the line of best fit, just put a check mark there. Yep, that's the line of best fit. Or ask yourself, well, maybe the line should be curved, so I'm going to put my check mark there that the line should be curved. Or no, maybe the line should be straight, so I'm going to mark that one. Or maybe I'm going to say, well, there's too many data points on one side. Or maybe the curve is there, but it's not smooth. It is possible to have more than one answer, but those should relate to each other. So you need to choose one of these responses right here. Then, second, if the answer is not correct, I'd like you to draw the line of best fit that you think should be on that graph. You can either draw it right on the same graph, or you can just draw another sketch of a graph someplace else, like this one right here, and just rough in those data points, put them in and just say, okay, well, I think the line should be like that, or whatever it happens to be, okay? But I want you to correct each one that's wrong. There's a series of 4 or 5 of those. Then there's a couple that you need to actually draw the line of best fit yourself. Then, near the end of the second page, there's a reminder of how we write the description when we are describing the variables on the graph. It will give you a reminder of how to do that. It gives you the rule again that I've already given you, and it gives an example of what the statement might be. Then I want you to go back to each of the problems on the worksheet, and I want you to write a descriptive sentence for each of the graphs that you see on that paper. So that's 3 things. 1, you're going to do the problems on the graph. 2, you're going to correct any of the graphs that don't have the correct line of best fit. And 3, you're going to go back to every graph and you're going to write a descriptive statement to describe what's going on with the variables in that graph. Then I have some reading for you to do as well. So there you have it. Enjoy the work this week, and I'll see you in class next week. Thanks.